In this series, we seek to present the latest trends in the circular economy, looking at case studies, looking at policy, and also to try and get a better feel for what people are doing well in certain countries and whether or not that is scalable. So today, I'm very happy to have the nice folks from Hanki Environmental and Industrial Company with us. The presentation will be led by Ambassador Raekwon Chung, who's an advisor to Hanki Industrial Co. He's a board director of the Ban Ki-moon Foundation, the first climate change ambassador of Korea, and the chairman of the new Climate Innovation Center at the Tashkent University of Economics in Uzbekistan. He'll be aided by Mr. Injun Park, who's the general manager of the energy division at Hanki Industrial Co. And Mr. Park is the general manager who oversees the energy division and also the accounting department, which is an interesting connection. So it tells you a little bit about the company. So I was very lucky to have visited this facility in Korea. So what I'd like to do is hand over to Ambassador Chung. Ambassador Chung, would you like to take over?
Future. Okay. Good morning, Steve.
Good morning.
Oh, you see some echo.
Yeah, you might need to fix that.
I will delete the box. Just a moment.
That's much better.
I will speak to Mr. Park's laptop.
Yeah.
Because we are sitting next to each other and there's some echo between the speakers. Okay, good morning. And thank you very much for the opportunity to present Hanki's Miracle Cube, which Steve visited a few weeks ago in Korea. And we very much appreciate Steve organizing this webinar that we could present a kind of, we believe it's a kind of innovation that can solve the problem of garbage, waste, and energy and the climate at the same time. So I'm very happy to have this opportunity. Thank you for the attention for everybody.
Thank you, Stefan, and Ambassador Raekwon Chung. Good morning, everybody. I'm honored to attend the ADB webinar. Let me introduce you to the people of our company first. After that, I'm going to briefly explain about the company and low temperature gasification of waste. Here is Ambassador Jung is an advisor for Hanki Industry, board director for Ban Ki-moon Foundation, the first climate change ambassador for Korea, and chairman of Global Energy Prize and International Award Community. I'm a presenting speaker in Jung Park. I'm the general manager who oversees not only the energy division, but also the account management department of the Hanki Industry. Here is Byung-eun Lee, professional engineer, energy division of the company. The engineer who specializes in saving the environment and energy by providing optimal solutions. Based on this dedicates of data collection and analysis, he takes pride in our products and hope to spread them out widely. Kwon Si-gu, technical manager, energy division of the company, an engineer specializing in design and construction. His main task focus on chemical engineering, power generation, firefighting, manufacturing instrumentation, piping, and electrical design. Our company is called Hanki Industry, which was established in 1992 and has been steadily running business in the field of environment and mechanical equipment for 31 years. Originally, we specialized in sewage treatment and incineration. Through continuous R&D for several years, we have developed a new technology called low temperature pyrolysis gasification. We call it Miracle Cube. As you can see on the screen, there are several types of incineration around the world, but most of the nations are using stocker type incinerator. Our company also used to manufacture and install a stocker type incinerator, But as a result of operating Miracle Cube so far, we have found numerous advantages than Stoker type incinerators. Miracle Cube consists of 3 pyrolysis furnace, and 1 by 1 pyrolysis furnace is operate alternately. Unlike Stoker type incinerators, gasification type inputs waste once or twice a day through an automatic system. There is no any driving divers during operation, so input waste can be operated unmanned. The biggest advantage of Miracle Cube is that there is no refractory repair and no cranker because of a low temperature operation. Miracle Cube doesn't inject too much combustion air, so it produces less dust and less exhaust gases. It's not necessary to install huge gas cooling facility and air pollution prevention facility. It's carried out at a low temperature of 250 to 300 degree, so heavy metals are not included in the syngas produced. Syngas from Miracle Cube is burned at a high temperature of about 1000 to 1100 degrees to completely eliminate dioxin and other toxic substances. As shown in the picture, it also maintains a constant amount of gas generation, so energy can be recovered stably. Miracle Cube can dispose all types of waste with a moisture content of to 20 to 25%. The reason why it can handle waste with high moisture content is that it recycles heat from the first reactor undergoing pyrolysis process to the second, and third reactor on standby for preheating and drying up the moisture content of waste for maximum efficiency. There are more advantages besides this, but I only explain it here for time. Ambassador Chung continue to explain more in detail about Miracle Cube. Thank you.
Hi, Steve. Can I continue to make a supplementary presentation?
Please do, Ambassador Raekwon Chung.
Okay. Okay. We are switching over to another PowerPoint. Are you seeing another PowerPoint now? It is uploading now. It is uploading. It says, yeah, it's sharing now. Are you seeing it?
Yeah, I'm seeing a different one, which is talking about low temperature gasification type and stoker type, a comparative one.
요거 좀 보여주세요. Oh, okay. Great. Then I will move over to Mr. Bak's laptop.
Terrific. Thank you.
Yeah, as you can see, maybe you're an expert already, so I don't think I have to go, the detailed explanation. But as you can see, the left-hand side, it is the pyrolysis reactor. It is a closed system, unlike the stoker, which is an open system, and that there has to be a crane operated by 24-hour manpower. So manually, you have to add trash into the furnace, but the pyrolysis system on the left side, you can just fill it up by one operation. You just close down the lid, so it will be a closed process. And in fact, you are not blowing any air into it. In fact, you are closing down the air. So it's actually you are sealing it off. But because if there's too much oxygen, it will make the combustion rather than heating pyrolysis. So this will show how this reactor is turning over the garbage waste into the fixed carbon after releasing all the sensitive gas. And the sensitive gas will be captured, and the gas will be burned around 1100 or 1200 degree. So theoretically, basically, there's no possibility of producing any dioxin. because the process itself is not burning, but it is just heating and burning the gas itself. And the gas does not have any dioxide material there because the temperature is already over 1000 degrees. Okay, next slide. Okay, this one shows how simple the process that of filling up the reactor. Unlike the other stocker type, you can just load it. Now at the current upgraded new reactor, this loading process will be all automatic. So you're just filling up from the trucks, and then it's automatically filling up the reactor. And then this diagram shows 3 or 4 reactors rotating each other. Okay, next slide. And this one is showing the problems of the stoker. As you already know, all the problems, the castable, the fire, resistant bricks, all these problems, the crank and all these problems, the great problems. And but I don't think, yeah, this is the problems from the stokers. But unlike the stoker types, the pyrolysis system does not have all these problems from the design process. So this one last slide captures all the advantage of using the pyrolysis, because first of all, the number one advantage is that this pyrolysis reactor does not need any fire protecting a firewall or fire bricks or castable to protect the furnace itself, because it's only 250 degrees. So it doesn't need any fire resistant bricks to protect the inside layer. So it is reducing a lot of cost, and you do not have to maintain the replacing the fire bricks all the time. So this is one of the most important advantage. And also it produces at least how many percentage? Because the ashes after the fixed carbon is produced, after waste is turned into fixed carbon, then this fixed carbon will be burnt with a little bit of a supply of oxygen at the later process. With a little bit of addition of oxygen, this fixed carbon will be turning into a kind of a powder type ash. This powder type ash is a little bit different from the ash, bottom ash from the stocker type. In most of the stocker type, the bottom ash is kind of a gravel, small gravel types. But because of the incomplete combustion process, which is unavoidable in many of the stokers, but in this pyrolysis Hanki Miracle Cube, the bottom ash will be just like a fine powder, like a flour. So it's very fine dust. And then this fine dust, because of this fine dust bottom ash can be even used. It doesn't need any landfill. It can be mixed up with the concrete and cement, and it can be used for road construction or any other construction materials. So it doesn't need landfill, and which is a very important factor, because in circular economy, if we produce something for landfill, it is not a very complete process for circular economy. But this Hanki Miracle Cube is producing only the fine powder that can be mixed, used to recycle for road construction, etc. So this is a completion of a circular economy process. And also, since this pyrolysis process is almost very close to complete or perfect combustion, the production of energy is almost 20% more than stoker type energy production. So it can generate more electricity and less exhaust gas, because we don't have to blow the air. So the exhaust gas is much less. Even the fly ash is much less than the stoker type, because in fact this pyrolysis system does not have any fly ash actually, because we do not blow any air. So the fly ash is almost negligible, and even the pollution level of the pyrolysis process, in the initial process, it is only less than 100 ppm. Even during the burning, synthesizing, heating process, it is only 500 ppm compared to more than 5,000 ppm of any other stocker types. So this is a whole lot of advantage. And also, as you can see at the bottom, the operating day is 330 days per year, much more than the stocker type. And so the maintenance cost, the cleanup process after the burning process is very small, because it doesn't need a lot of a huge process for cleaning up the air or the flying ash. So the whole system does not require a big investment for the cleanup after the burning process. So the whole process is a lot more efficient and much less pollution. And also, one more very important innovation of a Miracle Cube is that, as I said earlier, these reactors are operating in tandem with the 3 or 4 reactors all at the same time as a set, so rotating system. So these 3, 4 reactors are rotating each other, and the initial heating produced by the first reactor will be recycled to the second reactor, and this heat will be used to dry up the waste stocked up in the second reactor. So this heat is used to dry up the waste in the second reactor. So in other words, making the trash or waste in the second reactor to be ready for heating process. This is why this process, this Miracle Cube, can handle the waste, which is with a high content of waste. So this is a very important another advantage. And what else? There are too many advantages. So if you can come up with any questions, I will come back with a more detailed explanation. So I'll start here, and if there's any questions, I will come back.
Thank you, Ambassador Chung. Do we have any more component for this presentation?
Oh, that's all.
That's all. Okay. So I have a couple of questions, and we don't have many in the chat. But could we go back to the the isometric view of the 3 units in parallel? I just wanted to keep going. No,
different.
Might be the different presentation.
Okay. Just a moment.
This one?
This one? Or
no,
this
next one.
This one?
That one's the most important one. So if you have a look at on that, in the middle of that diagram, there is a deck on top of the whole thing. Directly under that deck, you'll see what basically look like buckets. What was very interesting was the doors into this facility. What I think the interesting thing about this is, once that material gets put in that facility, the doors close.
That's right.
Unless for it to be combusted. So this is a oxygen-free combustion component. Oxygen will be burnt off in the initial component, but this pyrolysis process, it's actually a sort of hybrid pyrolysis, hybrid gasification type process. This is why it's a bit unique. It's not you're not using not blowing air in, as Ambassador Chung said, but those blast doors, they're enormous. They're like 4 meters across or 5 meters across. They're very, very large doors, lids. And so I visited the process about 2 months ago. And what was quite remarkable is how clean it was as well. So this is quite an interesting process. We'll go to the questions if we can. And so I've got some questions. I'm just trying to open them up if I don't mind. So from Kin Chan. Kin, do you want to ask your question?
Sure, Steve. Hi everybody. It's Kin Chan. I'm from the department supporting PVPs in ADB. Thank you for the presentation. It's great to kind of learn these new technologies for waste management. My question is really related to the I think one of the slides that was highlighting the percentage of bottom and fly ash that was produced from this technology is around 2 to 3%. I just wanted to understand, in practice, what affects this level of generation of ash? Given the importance of, minimizing such generation, I wondered whether what are the key factors? Is it the composition of the waste? What else affects it? And does it vary, depending on the nature of the waste, for example, just wanted to kind of understand, what is the flexibility of technology for ash generation? Thank you.
Okay. Can I comment?
Please, go ahead.
Yeah. Thank you very much for the question. I think I'm not an engineer, but as I have learned a lot about this process. I think the key factor, as you can imagine, it depends on the quality of the waste you are getting. As you can imagine, sometimes these waste are sometimes mixed with the dirt, sand, stones. We cannot have a pure quality of waste. Much of those non-combustible elements are also mixed up. And it's almost impossible to separate everything in the pre-sorting process. So the quality of the waste will be the critical factor, because theoretically, any organic waste has to be decomposed with the synthetic gas, organic materials, and then the non-organic material is just a carbon. So it should be remaining as a fixed carbon. And the fixed carbon, as you can see the charcoal, imagine the charcoal, when you completely burning up the charcoal will turn into a kind of a fine powder. So theoretically, we should get, if the waste is a pure quality of organic material, the combustible material, then we should get only fine dust, just like after we get something after we burn the charcoal. But in reality, the quality of the garbage is not that great all the time. So all those non-combustible things are mixed up. Normally sand, dirt, and sometimes glasses. These kind of things are affecting the remaining bottom ash. Is this enough?
Yes, thank you so much for the clarification. That helps a lot. And therefore, I assume, the technology or the solution requires, the upstream screening or separation of such inorganic matter from the waste stream so that, the amount of ash that's produced is reduced. But thank you for that. That's very helpful.
Ken, if you don't mind, I'm going to add a little bit to that. And I think,
yes.
Yeah. So when you look at a stoker, that's basically driving heat up to a heat exchanger, which is above the unit. If you look at the configuration of these units, the process basically burns down. So you have various temperature zones as you go down. So what ends up happening is in the syngas, you get some uncombusted materials, but not a lot. And given the size and the complexity of the units, you end up actually getting quite low levels of uncombusted materials, which is a problem with gasifiers and pyrolysis units, generally some of the other ones. So this design component the design of this system has a different component. What ends up happening though is this material, this syngas, then gets sent off to somewhere to be combusted to make, in the case in Korea, it's made into heat, but it can be used, the syngas can also be used to generate electricity in a combustion engine. It can also be used in other processes to make, I was in India recently where they were making ethanol from syngas. So there is a number of end processes. The beauty of this system is it's quite robust. And the design of it is what suppresses the amount of fly ash. And so the configuration of it. So from a point of view of, is this a beneficial system for that? Yeah, I think that's one of its stronger points. Sorry to add in there, Ambassador Chung, I just wanted to add. Mark Brian Manlubatan from LRMC has a question. Mark, would you like to ask that question?
Okay, I'm now reading the question.
Yeah, Mark, are you online? Or would you like us to ask it for you?
Okay, now I see Mark's question. Oh yeah, a very good question. First of all, as I told you earlier, this pyrolysis system usually takes up only maybe half of the size of the land normally required by the stoker, because as I told you, this process does not need the huge clean up, back filter, and other processes to clean up the exhaust, fly ash. So the size of the land we need normally much less than the stoker. So city is much better than this kind of type will be much better. And how to ensure exhaust gases are safe? Oh yeah, as I told earlier, we are not blowing any air, so the exhaust gas is all very limited. And because we are not blowing the air, there's not much exhaust air to fly out from the whole process. In fact, we are closing down the system, so there's not much exhaust gas to be produced. But there are some at the last terminal stage of the burning up the fixed carbon. A little bit of air will be blown into the process. So the whole this volume of the air exhaust is much less than any other system, but we also come up with a cleanup back filter system as well, even though we have a very limited exhaust. So it will make sure the exhaust gas is much cleaner than any other system. And Steve have seen it in your site on the site that the NOx, SOx, and the CO levels are much less than even required by the legal standard in Korea. So, Steve, maybe you can comment on that if you want.
Yeah, I can. And what's interesting is if you have a look at the configuration you're seeing on the screen now, that's actually a very small footprint. That is probably the size of 4 floors of a car park and maybe 20 or 10 to 15 car parks in size for the actual unit. So when you look at the amount of space, that doesn't take a lot of space. What was interesting was that the unit that I visited was being used for area heating and providing heat to particular industries. And so there was some sophisticated back cleanup with DNSCRs and some of the other gas scrubbing material because they wanted a very clean quality of air into processes. And that was probably twice the size of these units. So what is interesting about this is that it can be configured into existing water treatment plants. It could even be configured into existing local spaces. So instead of needing 4 hectares or 3 hectares for a facility, you could probably do it. You could retrofit in, 20,000 square meters or 15,000 square meters of this into existing facilities. So that I thought was pretty interesting. It's really an industrial application. It's not a flat land application. So yeah.
Okay.
So Mark,
thank you, Steve. May I comment on that?
Please go ahead.
Steve, as you have mentioned, as you have seen, and Yangju in Korea, actually that was a kind of addition to the existing stoker system. So that site was very interesting because it is operating stoker as well as the pyrolysis system at the same time, one side, and they are saying they can show the comparison and the advantage of this system. Okay.
Yeah, I wasn't going to mention the stoker on site, but there you go. What's the name? It was interesting that they didn't want to share the comparative data because I think this system was beating them. Mark, have you got any other exhaust gases? Mark, the process of cleaning up the exhaust gases, you can fit on consumer industrial technology for things like if you've been to any of the waste to energy plants that ADB's built, we basically make sure that they install basically high-level gas cleanup materials. So the risk isn't really in air emissions, it's in what happens with the fly ash. And the challenge we have at the moment is we have systems that are making fly ash that need to go into hazardous waste landfills, and that's nasty material. So anything that can reduce that is a significant benefit. Mark, if you want to ask, you want to pipe up, please do, or if you don't, I'll move on to the next question. Okay. Ice, great question, Ice. The beauty of this system is that it's a lot more robust in the types of materials it can burn. So I'll let Ambassador Raekwon Chung answer that question.
Okay. Yeah. Thank you, Ice, for asking very critical question, because actually I forgot to mention about it. As you can see in this slide, there are 3 reactors in this diagram. The 3 reactors, as you can see, it can be closed down, so it can be sealed up, which means that in Korea, by law, we have to segregate medical waste, industrial waste, and domestic waste, and they should not be mixed up together. So we have to have a separate stocker for medical waste, industrial waste, and domestic waste. But in this case, the pyrolysis system, as these three reactors are all separate and closed system, this one set of rotating system can handle medical, domestic, industrial, all in different silos. So it doesn't handle all three types of waste in one site, in one rotating system. So this is another advantage of having this pyrolysis system.
Okay, and did you want to talk about the types of waste that the segregation necessary, and maybe put that into a discussion about pre-drying and drying of materials?
At least, just like any other incinerator system, Stoker and others, it's much better to have a good quality of waste. So we need at least pre-sorting process to take out all those non-combustible materials from the waste. I think it will be much better. And also, in this process, we do not have to segregate medical or industrial. It can be used in one system.
Yeah, that's a huge advantage. That is a really huge advantage. And what this means is that this system could be used as an adjunct to someone who's already got a system which is doing has stoker installations. This can be used to reduce emissions, but also handle industrial waste and medical waste. So that is a bonus. But I think it's very important that we don't just assume that this is going to handle everything. There needs to be recycling and sorting and those other value-added activities before you get to the materials. So Kiyoshi, Kiyoshi-san, would you like to ask your question, sir? Oh, Kiyoshi, are you there? He might have got caught on a call. Okay.
Yeah.
Okay, so let me ask this for Kiyoshi. Please share some of the disadvantages of the pyrolysis gasification technology. I've got two that I can add, but Kiyoshi, there you go. Hello.
Yeah, great. I really enjoyed this session, and thank you for excellent presentation. Very interesting. Yeah, so any of those new technologies, we are really keen to learn from everyone, and this was very relevant and very interested in possible replication to our project. And, so when we have technology, we always have pros and cons. So you could please highlight that there was one slide talking about disadvantage. This was about, this is relatively new technologies, etc. So, but then if you could just share some of the disadvantages as well. So that would be useful for us to assess among the different technologies. But Steve, thank you for arranging this useful session. Thank you.
You guys need to go and visit this facility. Go ahead, Ambassador.
Yeah, thank you very much for a very difficult question. And, I have been learning about this process for quite a few years before, but I cannot come up with what could be the possible disadvantage of this system. Maybe price might be one of the a little bit of a disadvantage, because this process pyrolysis system cannot compete with very cheap stoker type, not very well designed, low level stoker type. I don't think this system can compete with those cheap stoker, low quality stokers. But in Korea, in the situation of Korea, the low quality stoker cannot be operated in Korea. It has to maintain very high quality of standard. Then the price actually doesn't matter. The price of stoker, high quality stoker, and the pyrolysis system is almost same. The price level is almost same. But in many developing countries who are choosing for cheaper, low quality stoker, then I think this system cannot compete with the low quality stoker. Then maybe the only disadvantage.
Okay. I'm going to give you one as well, Ambassador Chung. Could we go to the slide that talks about the temperature? I just wanted to point one thing out. Now, the beauty, if you have a look at this process, this is a batch process. So the reason why the stokers are cheaper is because they go, thank you, that's the slide, that they go consistently. They do have longer periods of downtime than this system would because they have more moving parts. But in terms of the disadvantage of this system as a batch process, it typically burns out for between 6 and 10 hours, depending on the materials. So if you look at this slide, you'll see the yellow at the bottom, and that yellow is where you have one process finishing, and then you have to do a primary ignition for when you put the materials in the reactor. You have to ignite them, and that ignition burns off the existing oxygen and initiates what is the pyrolysis / gasification model. Now, that process means that you need to have people who are pretty good operators. What I was really impressed with in Korea were the operators of this system were fantastic. It had a fantastic control room. It was extremely well managed. It was extremely well, the processes in it told us what the temperature was, what time was, gave us a great deal of information. To do this in some of our developing member countries, this is really suited to some of the larger industrialized or highly dense cities in our developing member countries, where you'll be able to get that type of engineering expertise and, process capability. That would be the only disadvantage. If we were to look at doing this in rural areas, it would have to be a different business model. Okay. Sorry, Ambassador Chung, but that's the only disadvantage I see. Okay.
Can I comment on that?
Please go ahead.
On that? Yeah. Actually, this system includes providing all those centralized monitoring system, and everything is included in the whole system. So we don't need the local engineering skills to maintain or to design this monitoring, operating this monitoring center. So even it can be remote control, even from the whole performance of each unit can be monitored in Seoul, and it can be controlled by Seoul. So it can be remotely controlled. So actually, the demands or local needs for high quality of engineering is not necessarily a kind of a limitation or a disadvantage for operating the system.
Okay, so that then leads on to the next question, which I think is from my buddy Terry Cho. Terry, you online, mate? He'll be clocking on in a sec. Terry's got some questions about, the economics and the footprint and everything else. Terry, are you there?
Yeah, Steve. Yeah, I'm online, but yeah, I'm online. Can you hear me?
Can, brother. Go ahead.
Yes. Great. So sorry, my camera is not working well. So yeah, this technology actually is not totally new, but you have. I am pleased to see. You have improved it quite a lot during the role, and then it become more operational, as the presentation has suggested. So I see to install disposal system for less than 100 tons per day, which is pretty much very inefficient for the stocker system. And then the pyrolysis system seems provide a very attractive alternative. So I just want to ask whether there's a more operational scale reference which we can take a look and then compare and convince our client to consider this kind of the higher advantages system for as an option for them to consider down the road. So I already put my question in the chat box, so feel free to have an offline discussion if necessary. So thank you, Ambassador. It's a really impressive presentation. Thank you.
Okay, thank you very much for the question. Yeah, I forgot to mention that one of the very interesting or important advantage of this system is our innovation of this system is, as Steve have seen it, but most of the pyrolysis system the scale and size is very small, maximum 5 to 10 ton per day. But the innovation of the system, this one scaled up for one reactor, 50 ton. 50 ton pyrolysis system is not existing as far as I know. Maybe Steve, you can talk about it.
There are not many
as far
of
as
them.
I know, the 50 ton size reactor is not operating as a pyrolysis system anywhere else. So this is the unique, but because the rest are only 5, at best 10 ton. So, but the another advantage of this system is that since this is operating in the batch system, so it is not just one reactor, but 50 ton size reactor can be added up. So it can be scaled up to 200 ton, 300 ton, even 500 ton, because it's just a matter of setting up batch system for 4 units of reactors. We can just add it up. So the scaling up of the whole size of the scale that they can handle is unlimited. Actually, it's only the limit is the money or the supply of garbage. So one of the very important innovation of this system is that it can scale up the size of the garbage it can handle. This is the very important innovation. And also why this one is operating in a batch system is also because as you all know, pyrolysis system takes a longer time because it's a very slow process. This is why this innovation came up with the 3-4 reactors at the same time. So when it is in full scale operation, 4 reactors are operating at the same time. So which means that the speed can be much faster than just one pyrolysis reactor operating. So this is another very important innovation. So I believe that maybe this is clarify your question. But at the moment, it is only one system operating in Korea. But now already Hanki is receiving a lot of orders from inside Korea. And so it will be within 1 year or less than a year, you can see a lot more system in Korea. And we are very much looking forward to reaching out to the Asia and the other countries. Yeah, thank you.
Thanks, Ambassador Chung. Ken, you had another question about internationalization.
Yes, so thanks, Steve, and thanks, Ambassador.
Mate.
I think the Ambassador already answered part of my question by confirming that there's one operational plant in Korea with a pipeline of more to come. So that's great. Thank you, Ambassador, for clarifying. The reason I asked this question is really about precedent. Most of the developing countries that ADB supports, one of the most important questions they always ask is, where has it been kind of operated, in other countries or similar countries? So to hear that, there'll be more in Korea is very important, because that's definitely going to help as we look to, apply potentially, talk to our counterparts in governments around the area. But I think the second question I had was then, in terms of the plant that has been made operational on the pipeline that you referred to, Ambassador, how are these projects going to be funded? Who's going to be financing the construction and ultimately the operation and maintenance of these plants? That's a question I have, especially in light of what ADB is seeing across our countries that we support, where the impact of COVID is that the fiscal envelope that most countries have is reduced, and therefore there's now a growing interest on bringing private investment into delivery of infrastructure such as these waste management facilities. So having that kind of precedent is very important. And then obviously I just wanted to understand how is it being financed in Korea, because again that might help us in terms of looking to communicate this solution to our government counterparts. Thank you.
Okay, thank you. In fact, in Korea, as Steve has visited, the site in Yangju has been operating already 7 years without any problem, without any kind of repair or maintenance. It has been operating 7 years without any need for repair or the operation. So it is there, and it will be within a year, because Hanki is receiving a growing number of orders inside Korea. So you can see within a year a lot more advanced upgraded system later. And regarding the financing, Yes, I also visited Indonesia and Kazakhstan and discussed this issue of financing. And unlike any other country in Korea, we have a very high level of garbage charge. So people have to pay for the garbage according to the volume of what they are throwing out. So there's a money flowing from the people who are paying for the garbage. So the financing is not an issue because the operator in Korean operator in Yangju or any other stoker operator, incinerator is a big business in Korea, the biggest business in Korea, because they are making around, how much money? How much is it? $300 per ton. They are incinerator operators are getting paid $300 per ton. So if you burn 50 ton a day times $300, you are getting what? $15,000 per day. So they are making huge profit. So the money is not an issue. Banks and anybody looking for how to build up incinerator in Korea. Even the foreign capital funds are looking for to buy up incinerators in Korea because they are producing a lot of profit. Okay, but in many developing countries, it's a completely different story. People don't pay for garbage. The government don't have money for it. So what I thought as a solution for many developing countries was they can charge garbages from industrial complexes, especially from foreign investors or foreign companies operating in Indonesia, in Vietnam, or these foreign companies are producing a lot of garbage. And this garbage has to be charged. And this charge can be used to financing the installation of this kind of a system in the country, in developing country, and that they can use this system to take care of the domestic waste as well. I think this is a solution for them because normally they cannot pay for this kind of, because people are not paying for their garbage, and the government do not have enough money. And also when they're burning it, they don't have any revenue except selling the electricity or heat produced by the pyrolysis system. They can generate some revenue from it, but other than that, they don't get paid the gate fee. The gate fee is very low in developing countries. So my suggestion for them was, why don't you charge the foreign investors for their garbage and install this kind of a facility? That was my suggestion. Thank you.
That's great. Thank you, Ambassador. I fully agree. It's a great suggestion. You're absolutely right in terms of the low budgets available and the lack of political support for increasing, collection fees. I think that's always going to be difficult in developing countries. And I think the solution that you have, where you have different silos for different types of waste, is great. As I was highlighted in your presentation, it means that you can cross-subsidize, ultimately, is what you're suggesting, Ambassador, to cross-subsidize, to kind of, bring in the revenues from those commercial, industrial, medical wastes, and then that will help to reduce the burden and cross-subsidize for domestic waste. So I think that's an extremely, practical approach, and certainly something that really can actually strengthen, I think, the discussions that you're having. And it's great to hear that you're already visiting Indonesia. Indonesia is one of the countries that ADB, is very keen to support. Steve's been working in it, so have I. And so I think that's a country where there's a lot of potential with this technology. Thank you so much, Ambassador. Back to you, Steve.
Thank you.
Yeah, thanks, Ken. Do we have any other questions? Has anybody raised their hand? I can't see any hands raised unless if we can ask this, we've got another 10 minutes, so we can, while we've got these guys here, we can ask them questions. There's two things I wanted to mention. We should be careful about confusing this with rotary kiln type pyrolysis, which is a horizontal pipe which is rotated and heated. They tend to smell quite bad. So they are not a very nice process, and certainly we get a lot of complaints if we were using them. This process, I think, as Ken and Ambassador Chung were talking about, the resilience component of it, being able to handle medical industrial waste, is a good fit. Just out of interest, ADB's waste is currently processed in a gasification type process but we can't go into detail of it because it's not public domain. But there are already these types of facilities, not at this scale, but these types of facilities operating in many of our DMCs. So I would be suggesting that this is not something that's new for the process. It's the scale and the flexibility of this system that's probably new. And Ambassador Chung, if any of our colleagues would like to come and visit your facility, and Mr. Park, would you be happy to receive them?
Of
Yeah.
course, of course, of course.
Okay. Well, anybody that wants to do a weekend in Seoul, it's a very short flight from Manila. It's a very, very pleasant trip.
You are more than welcome. We will be happy to.
So is there anyone else who has any questions, or we can wrap this up? Let me just see if there's one question in chat. Okay. That looks like we're a wrap. So, Mr. Park, Ambassador Raekwon Chung, thank you very much for your presentation. I think you'll find that there'll be a few people who will ask more questions. I also wanted to recognize some of our other friends from Korea who've joined this call, Dr. Som and Jun Ho. Just to let everybody know, ADB is setting up a knowledge hub in Seoul, and this visit to this facility was actually a pre-launch discussion to have a look at that facility, which was very, very, very interesting. And Korea obviously is a very high-tech country and is continuing to showcase solutions of this type, and we hope we can use some of these in our developing member countries. So on that note, I'll say thank you to everybody, and thank you.
Thank you.
Yeah.
Thank you.
Bye.
Thank you, everyone.
Bye. Thank you.
Bye-bye.
Thank you.
Bye. Thank you.
Thank you.
We can